One more topic on nomenclature is going to be acids. So if we're naming acids, they're going to fit into two general categories. Category number one is a non-oxy acid, which does not contain oxygen, and these are a little bit simpler. And the second is an oxy acid, which tend to sometimes become a little bit more complex. So first case is our non-oxy acid. In the non-oxy acid, the IDE suffix is replaced with IC. So when we look at these acids, and remember that acids typically start with a hydrogen, so we're going to name them as hydro, then the name, depending on what acid, we're going to have something else in there with an ic acid. So as an example, if we look at HCl, this is going to be hydrochloric acid. If we have HBr, we can say this is hydrobromic acid. Or if we have HF, we can say this is hydrofluoric acid. And I'm going to underline what I say when I talk about the parent structure up here. So they're fairly straightforward, but the second thing that we have to look at are the oxy acids. And oxy acids are named based on the polyatomic ion which it was formed from. And this is going to kind of guide us into what we're going to talk about, or how we're going to name these compounds. So, for example, again, from the chart earlier, if we have an ion that ends in an 8, we're going to replace that with an ic, an IC, then list a space, and then the acid. If the ion ends in ite, we're going to replace that ite with us, or OUS, then a space, then the acid. If we have a hypoite, we're going to replace that with hypo, then the parent name, then us acid. Then if we have a per 8, we're going to call that a per, then the parent, ic acid. So let's kind of go through some examples here of how we would use this little table to figure out what our acid name was. If we'll start with the 8s, so if our ion ends in 8, it's going to become an ic acid. So for example, if we have NO3 minus, remember that hydrogen, when it forms a cation, is going to be H plus. So we need one hydrogen to combine with the NO3 minus. So that's going to be HNO3. We're going to name this nitric acid. If we have SO4 2 minus, we're going to need 2 hydrogens to balance out the charge. So in this case, it's going to be H2SO4, which will be sulfuric acid. Again, anytime we have an 8, we use the ic acid. If we have an ITE ending for our ion, we're going to have an us acid. For example, if we have NO2-, our acid is going to be HNO2, and we're going to name this nitrous acid. If we have a sulfite, which is SO3 2-, we need 2 hydrogens, so it's going to be H2SO3, and this is going to be sulfurous acid. So the difference between nitric and nitrous acid is how many oxygens you have, as well as the difference between sulfuric and sulfurous acid. It's also the number of oxygens that you have. When you go from sulfuric to sulfurous, you subtract an oxygen, and when you go from nitric to nitrous, you also subtract an oxygen. In the cases where we have the per and the hypo, these are retained. So if, for example, we have ClO4- and ClO-, our HClO4 is going to be perchloric acid. And for HClO, we're going to have hypochlorous acid. And these rules are going to follow for all of the acids. So make sure you go back to the textbook and read over this section of nomenclature. And the best way to learn this nomenclature is to first memorize all your ions, then go through and do as many examples as you can based on this content.